lecture I have discussed about crystalline solid and amorphous solid. In this lecture I am going to discuss regarding the difference basis on the properties between crystalline solid and amorphous solid. Just recall what is crystalline solid. A crystalline solid is a solid in which atoms are arranged in a particular manner throughout the crystal, whereas in amorphous it is completely random. So let's check out what is there in NCERT. In NCERT, we have in last class discussed about this long range order as well as the short range order. Please mark this, very important. The short range order is basically used for amorphous and long range order is used for crystalline solid. As well as we have discussed quartz and what is the difference between quartz glass. This we have discussed. Now further moving to another property, that is melting point. Crystalline solids have a sharp melting point. That means they melt at a particular temperature that is fixed. Whereas amorphous solid, they start to melt and melts in the range of temperature. Okay, they don't have fixed temperature at which they can melt entirely 100%. That is called they have a range of temperature. Similarly, one more important thing is that the amorphous solid, please make it a mark, amorphous solid have a tendency to flow. So what we have learned in the first lecture, the solid, the intermolecular force of attraction is very strong. So they don't have fluidity just like liquid and gas. But what we are reading here, amorphous solid have a tendency to flow. But they flow very slowly. Very slowly. That's why we cannot see by our naked eyes. Example I can give you, that is if you have visited any old church or any old building, the window pane at the bottom, it starts to become very thick. Gradually over the years, what we have noticed, or the scientist or the observer had noticed, that the bottom part became thick and the top part became thin. Why? Because it is made up of glass. And what we have learned in the previous lecture, glass is an amorphous solid. And what we are learning here, amorphous solid have a tendency to flow, but very slowly. This is the reason, that's why they are called pseudo solid. What do you mean by pseudo? Pseudo means false. It seems to be solid, but it is actually a liquid. It behaving like a liquid. So it's a false solid. Another term which is used is called supercooled liquid. Supercooled liquid. So this is again very important. Please underline it. In future it will be helpful. Another very important property now we are going to discuss, that is anisotropic in nature. Before discussing it, come to this point. I hope you all have NCERT and look at that NCERT figure number 1.2. This is an arrangement of atoms in a crystalline solid. And crystalline solid, what we have seen, the arrangement is very regular throughout the crystal. Whatever the arrangement that we will find at the beginning of the crystal, that we will find till the end of the crystal. Right? Now, this looks like a crystalline solid. Now, if I go to the dogs are barking really very badly. I'm very sorry for the interruption. If I go to the middle of this crystalline structure, what we see, just notice this. This side we will notice blue color circle and this side we will notice big red circle. But if I cross this lattice diagonally, what we notice? First a big circle, then a blue circle, then big circle, then blue circle. Similarly, here also different pattern. Am I right? Let me draw it. See, when I am going this way, the pattern, just look at the pattern. At the left side, pattern is having only blue circles. But if I go diagonally, the right side, if I suppose to take the right side, will have alternative blue circle and alternative red circle. So what this signify? This signify that in a crystal solid, if I change my direction of navigation through the crystal, the property will differ because the arrangement of atom will vary. Because property depends on what? Property depends on the way atoms are arranged. If I go vertically, I will get only similar type of arrangement. But when I am going diagonally, the arrangement completely changes. So this property is known as anisotropic property. This property is known as anisotropic property. I am repeating it once again. In a crystal lattice, the arrangement of atom is fixed throughout the crystal. But if I move in different direction or navigate in different direction within a crystal, I will get to see different type of arrangement within the crystal. And this different type of arrangement will show different properties. This phenomena is known as anisotropic. Whereas amorphous on the other hand are known as isotropic in nature. So what is isotropic? Just make a reverse of anisotropic. Isotropic, what is amorphous? Just recall that. In amorphous, the atoms are arranged in a random manner. There is no pattern, everywhere disorder. Everywhere disorder. So if everywhere is disorder, the property will also be same. If everywhere is disorder, the property will be same. See, this is quartz, this is crystalline, everywhere is arranged. But if I go diagonally, see, I am getting this kind of arrangement. But if I go vertically, I come to see this kind of arrangement. So in every direction, atoms arrangement is different. So this is an isotropic. Whereas in glass, which is amorphous, the disorder or randomness is everywhere. So if I go vertically or if I go diagonally, doesn't matter because the disorder is everywhere same. So properties will be same. So when properties are same, wherever I am navigating in the solid, it is called isotropic. But if property differs, if the direction of my navigation differs, then it shows the nature of anisotropic. Okay, so crystals show anisotropic nature, amorphous show isotropic nature. I hope it is clear and it is very, very important. So now coming to this table. This is very, very important. After reading that content, please go through this table and this is very, very important. For your CBSE point of view, for your joint point of view, this is important. See, first property is shape. In crystalline solid, what we have seen, the atoms are arranged in a regular pattern. Fine. So it will definitely have a geometric shape, right? But if it is irregular, there is no pattern, there is disorder, then it will be irregular shape. Melting point, just now we have discussed that it has a very sharp melting point. Suppose I am taking a crystal like NaCl, sodium chloride. It is a crystalline in nature. It has a very sharp melting point. At a particular temperature, the cubes or the solid blocks of NaCl will melt. Whereas amorphous like glass, plastic, rubber, they don't have sharp melting point. They start melting or softening at a particular temperature and over the range of temperature, they melt down, but not at a particular temperature. Cleavage property. This is again important. Suppose I am having a solid and I am using a knife. My knife is not drawn very nicely. So I am using a knife to cut it. I just cut it. And then I got a two piece. This piece and this piece. You can see this, the edges are very neat and clean, sharp. So it is a crystalline solid. But if my edges are like this, so this is amorphous. Why? The answer of why is again in this structure. Look at this. This is crystalline. Atoms are arranged in a very good regular pattern, an entire crystal. So I will get similar type of space or the cleavage anywhere I cut it. Like if I cut here, again I am getting a sharp clean cleavage. Whereas in amorphous, it is random. If I need to cut, I have to go like this, because atom cannot be cut down, molecules cannot be cut down. We move our knives through the spaces between the atoms or the molecules. So the spaces are very disordered mannered available. In a very disordered manner, the spaces are available. So whatever I will cut, I will get this kind of edges. So it is not a clean cleavage. So I hope it is again clear. Next is heat of fusion. Heat of fusion is a temperature at which a solid melts down to a liquid at a particular fixed pressure. Since it has a sharp melting point, so it has definitely have a definite and characteristic fusion of it. That means at a particular temperature, it changes its state, that is from solid to liquid. So as the amorphous don't have a sharp melting point, so it is obvious that their heat of fusion will not be definite, because at a range of temperature they changes their state slowly. So they don't have definite heat of fusion. And isotropy just now discussed. Crystalline is anisotropic and amorphous is isotropic. Okay. Next is crystallines are solid in nature. Amorphous are pseudo-solids or supercooled solid. Why? Because they flow but very slowly. That's why this is used. Crystalline solids has long range order. Why the term long range order is used? Because their pattern is repeated throughout the crystal along the length of the crystal. That's why it is long range order. And it is short range order. Why? Because on every point you will find a different pattern or different arrangement of atom in an amorphous solid. This table is very important. Please go through along with the NCERT. Now come down to the next topic, that is our in-text question. I will discuss each and every question, either it is in-text or the example or the NCERT questions. So why are solids rigid? In the beginning, in the first class, what I discussed, that solid has a fixed volume, fixed shape. Why? Due to strong intermolecular force of interaction. That's why the atoms are very close. So they are rigid. Why do solids have definite volume? Same reason. And now classify the following as amorphous and crystalline. This is the homework. If you have time, please write it down in comment box. Among this, which are amorphous in nature and which are crystalline in nature? Next question. Why is glass considered a supercooled liquid? Because glass is a amorphous solid. For your convenience, I have the answer also. Glass is an amorphous solid. So all amorphous solid have a tendency to flow, though very slowly. Hence, glass is considered as a supercooled liquid. That is why glass window and doors become slightly thicker at the bottom than at the top with the time. And the last question is, refractive index of a solid is observed to have the same value along all directions. Comment on the nature of the solid. Would it show cleavage property or not? Again, this is important question. See, refractive index observed to have same value all the direction. When we are able to see the same property in any direction we navigate in a solid, it is in amorphous, because there is a disorder everywhere. So wherever you go, in whichever direction you follow, you will get similar property, because the arrangement of atoms are similar. That's why refractive index in amorphous or in an isotropic solid seems to be same. Now, if I cut a amorphous solid, since the order of arrangement of the atoms are in disorder, random, so I will not get a clean cleavage. Just now I discussed the atoms are like arranged this way. So if I use a knife, I have to cut like this. So this is not going to give me a clean cleavage. I hope you have understood till this. If you have any doubt, please write it on a comment.